In this video, we walk through how each result from the paper can be recreated using our interactive, browser-based visualization tool. In this part, the setup of the Chemistry Mapper browser interface is explained, along with the process of loading pre-computed mapper graphs of 2 million molecules and exploring them. Starting with the repository, follow the installation instructions by cloning the repo and installing the requirements. Once that is done, run the server. Now, go to the following drive link to access the library of mapper graphs and download the desired one. Once downloaded, place the CLI_examples folder inside the cloned repository. Now, open the server link in a browser and import the graph from the downloaded directory. The graph will be rendered. The layout and color of nodes can be adjusted as desired. Please go through the rest of the repository to get details of the other features. In this part, we explore the chain structures of the mapper graph. The component we've selected is the one included in the paper on the right. We now explore the molecules contained within the nodes of this component. The molecules shown in the panel below are exactly those belonging to the selected node. Notice how they match the molecules reported on the right. You can clearly see the heavy presence of amide bonds both here and on the right. We repeat the same process for the other node within this component. Now, we proceed to select another chain from the mapper graph. After selecting this component, we observe that it predominantly contains molecules with sulfone bonds, consistent with what is reported on the right in the paper. Here, we show how to reproduce the results from the section of the paper that analyzes the structural patterns of molecules across different branches of the mapper graph. The key observation is that branches of a component contain molecules with the same functional group. We begin by selecting the component shown on the right, which has been added in the paper. We then choose a node in branch 2 of this component, using the same branch numbering as on the right. Notice that molecules in this branch show a heavy presence of chlorine, just like the molecules reported on the right for this branch. We repeat this for branches 3 and 1. Selecting nodes from those branches and observing the strong presence of fluorine. Next, we perform a similar branch-wise analysis for another component. When we pick a node in branch 1 of this component, we see the same molecules reported on the right, containing long carbon chains. The same is done for branch 2, consistent with the patterns shown in the visualization on the right. Now we demonstrate how to reproduce the results presented in the paper, where we analyze the chemical property patterns of molecules across different branches of the mapper graph. The key insight is that each branch contains molecules with similar functional groups, which in turn give rise to similar chemical properties. We begin by selecting the component shown in the visualization on the right, which has been included in the paper, colored by average toxicity. We first examine a node in branch 1, which contains highly toxic molecules due to the presence of fluorine, matching the pattern reported in the paper. We then select a node in branch 3, which shows moderate toxicity with molecules containing chlorine, consistent with this branch on the right. Next, we turn to the component associated with solubility. Selecting a node in branch 1 reveals molecules with amine and alcohol groups, resulting in high solubility. A similar trend appears in branch 2, where molecules contain phosphate groups, again matching the molecules shown in the visualization on the right.